Okay, so we're trying to figure out whether this is true or false. And 47, what they're really asking is, what is the most zeros that a third degree polynomial can have? And if you're not sure, think about like an x squared. Like let's say a quadratic. What's the most times a quadratic can hit the x-axis?
As many times as it can.
Two times, because it's x squared.
Oh yeah. All right.
Think about x to the 1. How many times does it hit the x-axis?
2 times here.
1 time.
Oh, at one time.
1 time.
Never mind.
So the degree equals the number of possible zeros. So this is a third degree polynomial. So can it have 4 zeros if it's a third degree polynomial?
No.
No. It's an impossibility. It's an impossibility. So that one is completely false.
All right, false.
All right, so 49 has a bit more to it. I guess maybe we're going to have to outline these individually, so I'll try pasting this again. If a polynomial of even degree has a negative leading coefficient and a positive y-intercept, it must have at least 2 real zeros. So 49 definitely requires a graph. So it says if it's an even degree but a negative leading coefficient, that means it starts low and ends low.
All righty.
Do you agree with that?
I do.
Okay, great. The next thing is it has a positive y-intercept. That means it's up here. And you always want to sort of overdo it when you're trying to do these problems. So the next thing is that it's asking if it must have 2 real zeros. So this is where you have to know a little bit more about this type of graph. It could be that it's just negative x to the 4th.
Mm-hmm.
And that looks like this, plus 9 maybe. That looks like this. So that's a possibility. So does that have at least 2 real zeros?
Yes.
Yes, it does. Okay. But here's what's also a possibility. I'll draw essentially the same graph. It could come down, cross, and come back like that. But then what must this one do? Well, it can have at most 4 real zeros. So is this possible?
Mm-hmm. Yeah.
Yeah,
that's true.
So we're looking pretty good here. Now, so here's what we're trying to say is there a possibility that it starts low and ends low? It has to somehow hit here, but it doesn't cross at least twice. Like, is there a way to get from A to B to C and only cross 1 time or no times?
Oh, 1 time or no times? No, that's not possible. So this is false?
This is true.
Oh, it's true? Okay.
So like if it was false, you'd be trying to look for something that okay, so let's look at 51. The function defined by f of x equals minus 3x to the 4th plus 5 has 2 real zeros. Wow, that's actually kind of what we were just looking at. This one basically says the same things as up here. This is a even degree and a negative leading coefficient. So it's this and then it's that, right?
Mm-hmm.
So we already answered it. So 51 is the same as 49. It's exactly the same. It's just they give you an example of it. They're saying, okay, it has a y-intercept at 5, because when x is 0, it has to be up here at 5. And then how can you get down here? Well, you have to cross it at least twice.
Oh.
That's what it's saying. It's saying it must be at least this, or maybe it's something like this. but you get at least 2 crossings.
All right. On the number 53, I guess.
Yeah, a fifth degree polynomial function cannot have a single real zero. So whenever you get a not in there, I usually like to just read it without the not. And I'm just going to say can have a single real zero. So we're going to find the answer to this. And if this is true, then we flip it. If this is false, we flip it. But that's how I'd like to do these because it's much clearer in my head. So fifth degree polynomial, can it have a single real zero? Well, here is a fifth degree polynomial. Fifth degree polynomial could have 5 turning points. I'm sorry, 5 zeros. But there's also this thing about turning points. Do you remember that from class?
Yeah, I do.
So it's this number minus 1. So it could have 4 turning points. So here's a fifth degree polynomial. It crosses, turns, that's 1 turning point, turns again, that's a 2nd turning point, turns again, and turns again. So there's 1, 2, 3, 4 turning points. How many zeros does this have?
This one has just 1.
1 0. So can a fifth degree polynomial have a single real zero?
True.
True. So since this is true, the cannot means that it must be false.
Oh, okay. I see what you mean. All right. Now we got to do the evens. Let's go on to number 48.
Okay, I'm going to get caught up to here. Let me snip this picture in. Okay, the function defined by f of x equals x cubed plus 3x squared plus 3x plus 1 must have at least one real zero. So don't worry about this, because you could graph that, for example. Let's look at the characteristics of this. It's a 3rd degree polynomial.
All right.
That means that it could have 3 zeros, but it must have 2 turning points. So it doesn't really matter where you start the graph, but because this is a equals 1 is positive, the leading term is positive, this one starts low and ends high. So can you find a graph that goes from A to B that does not cross the x-axis? Like, is there a way to get from A to B and not cross the x-axis?
That's impossible, right?
It's impossible. So it must cross at least once. Now it could do this, and then it has 1, 2, 3 zeros, but it could also just come up and have just the 1 0.
Mm-hmm.
And we don't really know, but we don't need to know.
I see what you mean.
Okay, let's look at 50 now. The function defined by this has no real zeros. Okay, so what that means is it never crosses the x-axis. So this is true. Sorry, I guess I haven't been saying whether they're true or false. The last one was true. This is 0, 5. That's if you put f of 0 in, you get 3 times 0 to the 4th plus 5, which is 5. This part means it opens up, like it looks like this. So does it have any real zeros? No, it does not cross. So this I guess is true that it does not have any real zeros.
All right, on number 52.
52. they're giving you the expansion of this. They're saying, okay, here's what it is in expanded form, and here's what it is in factored form. This means that it has a 0 at x equals 1. So our graph, we know that at 1, but we're not sure whether it crosses or touches. But if we look at the x cubed out in front, the end behavior on that is that it starts low and ends high. Well, if it must go through this point, okay, well, worst case scenario is it just does that. Okay.
Mhm.
Does that have exactly one intercept? Well, it does, because this is the only 0 over here that's in factored form. It actually has a 0 at x equals 1 3 times. Okay, so there's kind of a built-in thing here. When you have a factor, it's x minus a to the n. Okay, if n is odd, that means it crosses. If n is even, it touches.
Oh.
So in your case here, because n is odd, n is 3, it crosses. That means it only has the 1 0.
1 0. Oh. So this true. So this one is true, right?
Yeah, so this one's true.
Perfect. All right. Last one should be.
So an even degree polynomial must have at least one. Oops, that's not what you wanted. I don't know why that copy. Get in here. An even degree polynomial function must have at least one real 0.
Mhm.
Okay, so like, see, these are. I don't feel like I'm being very helpful here, but I hope I am, because I can just tell you what it is, so you can see it. You've got to find the whether it's true or not. An even degree polynomial must have. So here's an even degree polynomial, x squared. X squared looks like that. Okay,
Mhm.
it has a real 0. It has a real 0 right there. So basically, what we're asking is can you make it so that x squared, some variation on that, does not cross the x-axis?
Can't you already do that because it just touches it?
Well, a touch slash cross. So if you go x squared plus 1,
yeah, you can do that.
you've done it. Or you can go minus x squared minus 1, and that's the one that goes down like that. So yeah, you can do that.
So true.
Well, it's not true. It does not have to have at least one real 0. We're finding counterexamples to this.
Oh, this one's false. All right.
Yes.
All right.
Okay.
On to number 59.
Okay, so 59 has a long list of like things that you're supposed to do with this. All right. I'm going to graph this in Desmos, and I'm going to actually have to switch screens to that because I think that will be the most effective way to learn this. So let me get caught up to you by graphing it, and then I'll share my screen with that shown. All right, so let me share that screen, and then I'll talk you through new share. Okay, so if you're seeing my screen, you should see the graph of this function. Now, what I see is that it kind of dips down and then comes back up. So what I really need to do is increase the y values. So go to the y settings. I'm going to change this to minus 20 to 20. I didn't quite get enough on either of those, so I'm going to change it to minus 40 to 40. So it worked here. I got a min, but I don't have that max. So I have to go up to I'm going to just go up to 80. That didn't work, so we'll go up to 120. There it is. Okay, so you play with the window until you get it right, just like you do on your graphing calculator. So there's stuff that we need here, and you got to be really careful here because there's a 0 kind of right near the y-intercept. but this is all the information we need from the graph. So I'm going to snip this back into our workspace, and then we can talk through how to do the rest of it.
All right.
And then I'll share that. Again, but without it, it's kind of hard to do this problem otherwise. So I'm almost there. Get this kind of going. Okay, so new share. Get back to our math lesson. Okay, should be seeing on my screen the graph of this polynomial. Do you agree with that?
I do.
Okay, so now we can actually go through the list of questions that it's saying, hey, what do you need to do? So A is determine the domain. So I guess I'll do it over here. So the domain, there's no breaks here. There's no discontinuities. There's no holes. There's no asymptotes. So the domain is minus infinity to infinity, all real numbers.
All right.
Part B is saying determine all local minimum points. So the minimum is this is the local min right here.
It should just be that one local min, right?
There's only one, and it says determine to the nearest hundredth. What's not clear is whether it's asking for both the x and the y. It should say what is the local minimum or provide the coordinate of the local minimum.
Yeah.
I would just give both. I would just give the ordered pair for now, since I don't know otherwise. Okay, and then maximum. This is the other one up here is the local max. It's sort of a hill or a peak compared to some of the other ones.
All right. Now you go on to D.
Yeah, so C is over there. C 0.07, 84.07. Okay, so D is saying determine the range. Okay, the range in this case, this thing extends up forever and this goes down forever, so much
So
like
all
the
real
domain.
numbers.
Yeah.
All right. Okay. E, determine all intercepts.
So that's what's so nice about the Desmos here is we got them all. It's -6, comma, -3.19 and 2.19. Just read them off the graph there.
Perfect.
So now the real, probably the real questions here that might be new is F and G, increasing and decreasing. So increasing, as we talked about, is going up and to the right, and it's the X values. For increasing and decreasing, you're always using the X values.
All
so
right.
in this case, it's -4.74, comma, 0.07. That's where it's going up and to the right. I can draw it on here, increasing along here. So it's decreasing now. It's decreasing now, going the other way. Decreasing down here, decreasing down here. So it actually is two intervals, -infinity to -4.74, comma, 0.07, comma, infinity. I'll be right back.
All right.
All right, Jack, I'm back. Is there
Perfect.
anything on that that's, is there anything we need to review from that? Because it really all comes from the graph. If you have the graph.
That's fine. We can move on to the worksheets that I have. I'll send them to you right now.
Okay, great. I will stand by.
I can just email. I can probably just like share it in a copy of a doc with you.
Sure,
This will
whatever
be
whatever you need
much
to do, I'll work
faster.
with. Okay.
All right. Now, this open. Make a copy of this. Well, that's unfortunate. I'll have to send screenshots. Perfect. I got a screenshot. I'm gonna send it to you by email.
Okay.
She sends shortly.
All right. Looks like I got something. Not yet. Not yet. That's something else. There it is. Okay, so you did send some screenshots. That's fine. Um, Rational expressions. Is that where you want to start?
Yep.
Okay. State the excluded values for each. Is that correct?
That's correct.
Okay. Sorry, we got to over communicate in this format. Otherwise, no one gets out of it what they need to. So, um, okay. So when it says excluded values, what they really mean is where's the function undefined, but they're not even giving you a function, so it's a little bit weird. These worksheets are terrible, but they're great for teachers because they can just grab them, print them out, and send them to you guys, and you know. But really, it should say f of x equals 60x cubed over 12x. But actually, to do what they're asking you to do here is you're essentially looking at where the denominator is equal to 0. So you literally set
X equal to
12x,
0.
x equal to 0, and you solve for x. So in this case, you'll find that x equals 0, and that is the excluded value. So this turns into x cannot be 0.
All right.
So 2 is exactly
it?
2 is exactly the same. 3 requires slightly more stuff.
All right. So that'd be b squared over 100v B cannot equal 0. All right, number 3. Do I need to factor out number 3?
All right, I'm back. Did you get for 2 that v equals 0?
Yeah.
Okay.
All right. So for the next
Okay.
one, do we have to factor it out and then find the zeros in that
Exactly.
in the bottom?
Yes.
All right.
Just the bottom, not the top. The top you can ignore for the purposes of this assignment.
So m cannot equal -7 or +3.
Yeah, it's a little odd to write it that way, but that is exactly how you need to present your answer.
For 4, n cannot equal -1.
That's right. So 5 is the same.
25x minus 40 equals 0. 40 plus 40. And I'll simplify to x cannot equal 8 over negative. Is it just 8 over 5?
Yes.
Okay. Number 6, we can factor that out. Turn into, what is it, -7. Yeah, it should be like n minus 7 times n plus 5.
Uh-huh.
All right. All right. On number 7, simplify each and state the excluded values.
Okay, so let me jump in here because I believe I need to give you a little more explanation on this. What they're doing is they're leading you towards how to graph rational functions. The excluded values you actually do before you simplify. So you have to do this first and then do this second. If you do them in the wrong order, you miss out on one of the values.
Okay.
So in this case, just factor the bottom, and you've already done this a couple times. It becomes p plus 2, p plus 4, okay? And you might say, oh, well, I can cancel this. Yes, you can. That's number 2, though. So number one is to say that p cannot be -2 or -4.
Mm-hmm.
Now, when you simplify, yeah, you're going to cancel those out, and you're going to get 1 over p plus 2. See how if you try to figure out the excluded values here, you're going to miss that one.
A whole? Oh wait, no. Yeah,
well, it is a whole, but let's. So again, you kind of got to do this in the right order. Otherwise, it's. So let me grab 8 here. So there, like, one of the things that I think may be unclear here is like you can do some things to make the bottom simpler without like avoiding without you're not violating what I said about doing them in this order. This just makes it easier to see that A cannot be 1 in number 9.
All right.
Okay, but then you have to simplify this 9 over 15, so it becomes 3 over 5 A minus 1.
All right, now we're You scroll up again real fast.
Yeah, sorry about that.
It's all good. Perfect. All right, now on to number 9. All right.
So 9 here, it's got a lot more going on. And this is the first time you're going to have to do stuff to both the top and the bottom. But again, the bottom, so there's kind of, I feel like I keep contradicting myself, but there's really a 0 step, which is to factor everything first. You're not simplifying. Factoring can some ways make it worse. We've mostly been focusing on the bottom, but really you need to factor both the top and the bottom. So like at the top, there's a 2a in both. And at the bottom, there's a 3a in both.
So the top and the bottom cancel like that.
No, we don't do that yet. We don't do that yet. The first thing is like when you factor, then your first step is to determine the excluded values, which is setting the bottom equal to 0.
It should be 0 and -5, right?
So a cannot be 0 or -5. Then you can simplify. So notice factoring is not the same as simplifying. They're not. And here, yeah, you're right. A lot of stuff cancels. It actually just becomes 2/3. The a's cancel, and the a plus 5's cancel. But you can't just, you can't just jump
straight from A to B.
Yeah, you can't go. Yeah, you can't go from step 0 to step 2. You're going to miss a bunch of stuff. And so this is why I don't like even teaching it. I would never teach it this way, because you really should factor everything. And that's really, we're finally up to some problems where I need you to factor everything, but do not simplify. You need to be able to factor the top, and you need to be able to factor the bottom. And that's, we call that step 0. That's where you're starting.
All right. Nice. Set them all. The denominator equals 0, so p cannot equal -2 or +1. And now we can simplify it out. It just turns into p minus 5 over p minus 1. Is that it?
That's it.
Perfect. All right. On number 11, we can simplify these now pretty easily. So we got a vector up at top. Oh. All right. All right. Number 12. It should be like x plus 4 times a plus 4 times a plus 1 over, what should this be? a plus 5 times a plus 4.
Yep, that's right.
A cannot equal -4, -5. Now cancel those out. Should be like a plus 1 over a plus 5 on to 13. You gotta keep on simplifying.
Are you writing out the excluded values?
Yeah, I'm making sure to do that.
Okay, great.
X minus 5 times x plus 3 over x minus, wait, what? Oh, is it x minus 5 times x minus 1? Or for number 13, how do you factor that one out?
The bottom or the top?
The bottom.
The bottom is x minus 5, x minus 1.
Oh, okay. All right, and the excluded values of this are cannot equal 5 or 1. And the whole thing should turn to x plus 3 over x minus 1. 14. What? Doesn't that just turn to 1? Over 14?
It does, but you have excluded values that you can write out before that.
X cannot equal 2, 4, 6. Cannot equal 3/5, and it just equals 1.
Yep. Good. So 15 starts something slightly new, different, I guess. You have to remember that division is the same as multiplication by the reciprocal.
So it's just v minus 10 over 1.
Yes. And that will it will help you to cancel out stuff, because otherwise you won't see any cancellations. It's a lot of writing, but it's you end up getting to cross out, which is nice. So here you can cross those out. You still have to say v cannot equal -8, v cannot equal 10. But then you're left with v minus 7 over v plus 8. Nope, those cancel too. I didn't even notice that. So then you're just left with v minus 7.
All right. Under 16. We do the same thing.
Yes.
N plus 2 over n plus 3. Multiply that by n minus 1 over n plus 3 over n minus 1 squared. What do we do with this, with the bottom? Like I know that n cannot equal -3, but what about the -1 squared though?
Let me get a chance to get caught up with you, because we got to be talking the same language here. So you're gonna multiply by n minus 1 squared over n minus 1 n plus
Wait,
3.
don't you flip the n plus 2 and the n plus 3?
Nope, you flip the second one.
Oh, you flip the second one? Oh.
Yes, multiply by the reciprocal.
All right.
So there's 3 excluded values here.
All right, so cannot equal -3, -2, or 1. Now we gotta simplify these out. We can simplify the n plus 3 on both sides. Can I get, what do we do now?
Well, the n plus 3 cancels with this n plus 3. There's
Right.
2 n minus 1s up here. So if it's more helpful, you can write it out as n minus 1 times n minus 1 and get rid of that. And then one of these cancels one of these. So you're left with n minus 1 over n plus 2.
Okay. That makes sense. Now we go over to number 17. X plus 3 over 4 times 6.6. X plus 3. So x cannot equal -3, right?
We're on 17. Yeah, x cannot be -3. That's right.
Now I can simplify these out. What about the top and the bottom 3?
They cancel as well.
All right. So you're just left with x minus 6 over 4, right?
Mm-hmm.
Perfect. All right. Got 18 x minus 8 over x plus 6 times x minus 8. Multiply that by 4x times x plus 10 over x plus 10. X cannot equal negative 6, negative 10, or 8. And so now cancel out the x plus 10s and now the x plus 8s. And so I should get 4x over x plus 6 for that case. Is that true?
Or x over, yes, x plus 6, that was good.
My handwriting is terrible. I need to fix that. All right, there we go. And now number 19. 2b squared minus 12b over b plus 5. Now I multiply it by b plus 5 over b minus 6, right?
So you got to flip this one as well, right?
Mm-hmm.
Did you do that already? Yeah. So it becomes you should get a 2b. It's just reduced to 2b. Is that what you got? Or do you want me to work through that one?
Can you work through this one with me?
19, sure. This is the limitation of this, where I can't see what you're doing because it's so impractical to try and get that. This one, you want to factor the top.
Yeah. All right.
And then you flip the right side. Okay, so now you're multiplying them. And then it's just a matter of canceling.
Ah, there we go. All right.
So you can see it really looks nice when it's all done.
B cannot equal negative 5 or positive 6. All right, now cancel those out, cancel that out. And it's just 2b, right?
Yes.
All right. Now I go on to number 20. All right, 1 over n plus 9 times 3n over 8 minus 18 over 6 minus n. N cannot equal negative 9 equals 0 minus 6 or 6. Positive 6 can't equal positive 6. And 3n times 3 times 3 times n minus 6. Can I not simplify this one? Say this one out?
We're talking about 20?
Yeah, because you can't.
There's a small little wrinkle in this one, which we haven't covered yet, which is factoring out negatives. That it's really not difficult, but you've got to know what to do. So on the right here, this first becomes 3n minus 18 over 6 minus n.
I simplified it up to 3 times n minus 6 on the top.
Right. But on the bottom, you can factor out a negative 1. So this is what's a little bit odd. It's really negative n plus 6. So when you factor out the negative 1, it becomes n minus 6.
Oh.
And then you get some nicer cancellations. So obviously those cancel. The negative usually you bring up to the top, so this becomes negative 3 over n plus 9.
Oh, I see. On the number 21, so I can. Oh, this one's a little difficult. 28 minus 7 and b over.
Just factor out that top one, top left, and you'll see the cancellation. This one you have to do the negative again with the factoring. So like the top factors into 4 minus b over b minus 4. Whenever you see, it looks the same, 4 minus b, b minus 4. It's not the same, but when you see the same things, that's your hook, your indicator to factor out a negative. So 4 minus b is really negative b plus 4, just rewriting it. So when you factor out a negative, you get b minus 4. So that negative comes out in front, it becomes negative 7 b minus 4 over b minus 4 times 1 over b plus 10.
There's a negative 7 over b plus 10, right?
Yes. So it becomes -7 over b plus 10.
Perfect. 22. That actually works out nicely.
It does. What does it reduce to?
First, I got to factor out the bottom and see what it turns into. So it should be like.
Well, but okay, so you're missing that they're the same. That the top right and bottom left are exactly the same.
Yeah, I see that.
Oh, okay, great, okay. So, and
So
we're not even
bottom.
doing what the b's cannot equal and the v's cannot equal. I mean, I keep forgetting to do that for you, but
And it's like v cannot equal. What is it? 9 and 3.
Yep.
And I could just cancel out and 3 in the bottom with the other one. So it'll just turn to 2/3.
2/3.
22. 23. This one's has a little wrinkle again.
These are the exam quality questions you're going to see, the ones down here at the end, because they're the most intensive. The first step is to change division into the reciprocal or factor either one. You've got to get through those two. Now we got to factor the top and the bottom. Sometimes it could just be hard to know what to factor. This one becomes 9 times p minus 4.
What do we do next?
Do you see any cancellations? Well, okay, let's do the p cannot equal 0 or 4. I got to keep remembering to do that. Do you see any cancellations? Because you're canceling either diagonally or vertically. So those cancel. And then so you're so used to stuff canceling that you miss that it doesn't always have to cancel.
Mm-hmm. All right.
Well, we're gonna have to stop here. I do need a short break. Definitely queue up whatever you want us to
go with next. Yeah. I'll send those to you.
All right, thanks, Jack. I'll talk to you shortly.
All right, see you later.
Okay.
Bye-bye.